Your Maytag gas dryer runs but doesn't heat? The issue usually lies within the ignition system. We'll focus on three main components: the igniter, gas valve coils, and flame sensor. Here's how gas flows through the system, from the gas valve to the igniter, then to the burner. The igniter is a glowing element that lights the gas. Gas valve coils control the gas flow. The flame sensor detects the flame to maintain gas flow. These parts work together to ignite the gas and maintain the flame. When one fails, the dryer runs but produces no heat. The igniter is the glowing ceramic element in your Maytag gas dryer that heats up to ignite the gas. Here's how it works. Gas flows from the valve to the igniter, which glows hot to light the gas before it reaches the burner. The igniter often fails due to breakage, lint buildup, or electrical shorts. When faulty, it prevents the gas from lighting, resulting in no heat for drying. To diagnose, first check for visible damage. Then use a multimeter to test the igniter's resistance, which should measure 2 to 4 ohms. Gas valve coils are electromechanical solenoids that open the gas valve when energized by the control board, allowing natural gas or propane to flow to the burner. Here's how the gas flow works. The control board sends electricity to energize the coils, which magnetically open the valve, releasing gas that flows to the burner where it meets the glowing igniter. These coils can malfunction due to worn-out solenoids, poor electrical connections, or thermostat problems, blocking gas flow even when the igniter is glowing properly. The result is a dryer that runs but produces no heat, as gas cannot reach the burner to create the flame. This gas valve anatomy shows the key components, including the coils that control gas release. To diagnose coil issues, technicians use multimeters to test electrical continuity and resistance. The flame sensor is a crucial safety component in Maytag gas dryers. It's a metal rod positioned near the burner that detects the presence of a flame by sensing heat. When the gas ignites and produces a flame, the sensor conducts electricity better due to the heat. If no flame is detected, it immediately signals the control board to shut off the gas valve, preventing dangerous gas buildup. The flame sensor can fail due to common issues like lint and debris buildup that insulate it from heat, corrosion from moisture, or misalignment that prevents proper flame contact. To fix a failed sensor, gently clean it with fine steel wool to remove debris, or replace it entirely if it's damaged or corroded beyond repair. Start troubleshooting by understanding the gas flow path in your Maytag dryer. Gas flows from the valve to the igniter, then to the burner, with the flame sensor monitoring the process. First, ensure your gas supply valve is turned on and the dryer has adequate gas pressure. No gas means no heat, regardless of other components. Next, inspect the dryer venting system for blockages or restrictions. Poor venting can prevent proper airflow and cause heat issues. Check for lint buildup, kinks, or excessive length. Start a drying cycle and observe if the igniter glows orange for 20 to 30 seconds. The igniter heats to ignite the gas. If it doesn't glow, it's likely faulty from breakage or contamination. If the igniter doesn't glow, replace it. This is the most common cause of no heat issues, often due to lint buildup or electrical failure. If the igniter glows, but there's still no heat, check the gas valve coils and flame sensor. Coils may be worn out, or the sensor may be coated in debris, preventing flame detection. Use a multimeter to test electrical continuity. Check igniter resistance, 2 to 4 ohms, gas valve coil continuity, and flame sensor voltage drop when heated. This confirms if components are functioning electrically. A common DIY fix for a faulty flame sensor involves cleaning it with steel wool to remove built-up debris and restore conductivity. Before cleaning, the voltage might read 0 volts due to contamination. Use steel wool to gently scrub away lint and debris from the sensor rod. After cleaning, when the flame is present, the voltage should jump to around 1.2 volts, indicating proper flame detection. This simple fix can save you a service call. Refer to Repair Clinic's videos for visual guidance on the cleaning process. The gas flow path runs from the gas valve through the burner, where the cleaned flame sensor ensures proper ignition. Many newer Maytag models from 2025 onward feature built-in self-diagnostic modes that you can access directly through the control panel. These diagnostics allow you to run specific tests, such as checking igniter resistance and flame sensor voltage, which are crucial for the gas flow system. You can test igniter resistance, which should typically measure between 2 to 4 ohms, and flame sensor voltage, which drops to near zero when a flame is detected. Advanced models may include IoT connectivity, enabling remote diagnostics through smartphone apps that alert you to potential issues before they become serious problems. Future dryers will feature solid-state igniters and wireless sensors, making replacements easier and more reliable. Proper venting is essential to avoid many heating problems in gas dryers. According to the Appliance Repair Institute, 70% of no-heat issues stem from igniter or sensor failures. Regular maintenance, like cleaning the lint trap after each use, can prevent expensive repairs. This animated diagram shows the gas flow path from the valve to the burner, highlighting the critical components.